We've learned a lot about Google Meets. All right, I'm going to go ahead and present because I get to start with you guys today. Andy, I need you to go work on your stuff.
Hi.
Okay. All right. So we are going to go ahead and start. You should be hopefully seeing my screen, and we should be in unit circle-ish kind of stuff. I'm starting with example 7. Correct, Ms. Rondo?
Correct.
Okay, here we go. So I have the terminal side of theta on a given axis, okay? A given specified quadrant. Find the values of the 6 trig functions of theta by finding a point on the line. This one's a little bit goofy, okay? So basically they're having us draw this this value, okay, or this equation of this line. So I'm going to go ahead and just sketch it using a sloppy graph. I have to graph the line 1/2 x, so I know that my y-intercept is 0, and that I know I'd have to go up 1 over 2 for my slope. I'm going to go the other direction too, just so I get a nice line, and that will help me hopefully with my triangle. Oh, that was nice. Hopefully help me with my triangle drawing later. Okay, so it also gave me the information that I'm in quadrant 3. So I know that this triangle that I need to sketch is not in quadrant 3. Okay. So I'm going to try to find the sides of that triangle now. I know that if I count out to the left, I went out 2 to the left, so that would be -2. And I would know I went down 1, so that would be -1. All right, I'm going to ask a question in the chat. Let's see if they remember what they have to do. Okay.
Okay. Sounds great.
I need to find the hypotenuse, everybody. So how would I find the hypotenuse of that triangle? Who would be our friend in finding the hypotenuse?
Gonna take him a minute to type that in. Oh, we got one. Hold on, I'm
Who's
gonna see
our
if
friend?
anyone else. So the one answer we have right now is Pythagorean Theorem.
That sounds great. Pythagoras is like my absolute favorite. So I know a teacher when I first started teaching who got to go to prom with Pythagoras. I was super jealous. And don't tell my husband. So because I'm too young to have gone to prom with Pythagoras, gone to prom with Pythagoras. So all right, I'm going to use my legs. So you've got -1 squared plus -2 squared, and that's going to equal whatever that is squared. I could put an X. I'm going to use a question mark because it really doesn't matter what I put there. All right, so -1 squared is 1. -2 squared is 4. My thing is acting silly today. Equals, and then question mark squared. And I know that 1 plus 4 is 5, and then I'm going to take the square root of both sides. And we've talked to, or Ms. Rondeau talked about yesterday, that when we take the square root of both sides like that, we'll only do the positive when we're doing the hypotenuse here. So I know that that leg, or that hypotenuse is 5. Now I need to actually I need to go back and figure out what I was supposed to be doing here. I'm supposed to be finding the values of the 6 trig functions. So that means I need to evaluate. I need to write down what sine is, what cosine is, and all of that. So sine, they didn't really give me an angle. Oh, they said theta. So and theta would be. I'm going to try to squish it in. I drew it too small. Let me use a different color that would stand out. So theta is going to be right in there. Okay. So the sine of theta is the opposite, which is the -1, over the hypotenuse, which is the square root of 5. Now, I know I don't like to leave it like that, but before I tend to do the rationalization, I know that I'm going to flip the reciprocal, so I'm going to do that first. That way I don't lose that reciprocal, and I don't forget that I had to do the flip with this and don't have weird unrationalizing, and that's a negative sign in front, so it's really just negative. Getting all kinds of weird tails today. Square root of 5. So I'm going to rationalize this, and we told you at the beginning of the unit you're going to have to do this thing a million zillion times in here. So square root of 5 times square root of 5 is 5. All right, so that's sine. Let's do cosine. So cosine of theta equals the adjacent over the hypotenuse. So my adjacent is -2. My hypotenuse is square root of 5. Again, I am going to choose, I'm going to put my work up here, the secant I'm going to choose to flip the secant right away. So I've got negative square root of 5 over 2. Does not matter where your negative sign goes. It can float to the top or the bottom or just in front. And then I'm going to choose to rationalize now. So negative 2 square root of 5 over square root of 5 times square root of 5 is itself 5. All right. And then I need to do tangent because that's what's left. So tangent, and that is the opposite over the adjacent. So negative 1 over negative 2, which is positive 1/2, which makes sense because remember we talked about all students take calculus. It makes sense that tangent went positive in that quadrant. And then cotangent, I just flip the reciprocal for tangent, so I get 2 over 1. How are we doing? Any questions, Miss Rondo?
I didn't see any, but I went away for a second. Okay, nope, we're good.
Okay. All right. Now we are supposed to evaluate the trig function of the angle, or the trig function of the quadrant angle. And all the quadrant angle is an angle that is on an xy axis. So the angles that we're talking about are pi over 2, pi, 3 pi over 2, and I should have really started with 0, either 0 or 2 pi, because remember 0 is also an angle. And notice I've switched, it's all in radian right now. We kind of have, we're going to start moving away from degrees a little bit more today. It's in there a little bit. We're going to start moving more towards the radian measure than the degree measure. All right. I do have the unit circle sitting over here, so I'm going to use that. If you hopefully have a picture of it out. If not, you can always sketch and just know that you have these coordinates on there. You can always do that little quick sketch.
Mrs. Ballard?
Yes.
I have a question.
Yes.
If you're doing the quick sketch, how do you know that the number is 1 in your ordered pair?
Because the length of my radius of the unit circle is always 1.
Oh, got it. Okay.
Yes, always 1. And then remember we had the shortcut that I don't like the other day, where it looks like -10 and that looks like 10 with a comma in it. I don't like that, but sometimes it works for us. So it's the only reason I bring it up. All right, so I've got the sine of pi, and I could either use my quick sketch now that I've got it, or I could use this over here. Doesn't matter. Sine, remember, is the y value. So I'm going to look at my y value at pi, and I'm just going to look at the sine of it. Actually, so it says evaluate, not look at the sine. So we're going to evaluate it, and so we know that the sine of pi is equal to 0. I'm going to go to cotangent, and we did have some identities the other day where we talked about that cotangent is equivalent to the cosine divided by the sine. So I know that I have to put the cosine over the sine when I do cotangent. So I know the cosine is the x value, so that's going to be 0. And the sine is the y value, so that's going to be -1. And 0 divided by -1 is 0. And then finally, we've got the secant of pi over 2. So secant, we know, is the reciprocal of cosine. So I'm going to take the cosine value, I'm going to do 1 divided by the cosine value. In this case, cosine is x, so I'm going to put, and it's 0. So I know I can't have that, so I would write that this is undefined. All right. We're going to talk about a reference angle. And where are you taking over? I can't remember, Miss Rondo.
I am taking over at example 16, and I think actually based on looking at it, I might just do the 22 to 25 to finish it.
Got it. Sounds
I'm
good.
sorry.
No worries. No worries. Okay. So we're going to talk about the reference angle. And we kind of have done this a little bit already with the triangles. We've really come up with that the reference angle is a 30, a 60, or a 45. And so we've kind of already seen this. So I'm going to try to do my best to try to explain this, but sometimes we can just kind of go back to the triangles that we've drawn or the triangles that we've matched out of our unit circle. So let theta be an angle in standard position. And this word in here is supposed to be reference angle. I'm sorry if there's not enough space to write that. Is the acute angle, and it's got this funny little symbol on there. When we see that funny little symbol, they've seen it before.
They've seen that in geometry. They know it's prime.
Do they call it a prime in geometry?
Yep.
Okay. All right. means something else in calculus. So
It does, but
yeah, and it just means that that's just a notation for that it's the reference angle. So it's kind of like the angle, but it's kind of its buddy, its friend, it's its reference angle. So it's formed by the terminal side and always the horizontal axis. So if we look at this first picture here, we know that if we draw this obtuse angle here that lands in quadrant 2, so the angle we're actually looking at is that angle. But we know it refers, and I kind of scribbled over the top, it refers to, or its reference angle would be this, as in if I drew a triangle in there, that triangle that's between the terminal side and the horizontal axis, that whatever this angle measure is in there would be its reference angle. So we would base all of our trig identities off of that, or trig functions off of that angle. In order to calculate this, now personally, I think I would count it out the way we've been doing. But if you want to actually do a calculation, you would either do pi, because this whole thing is either at pi or 180 degrees. So you would take pi and subtract the angle that they gave you, or you would take 180 and subtract the angle that they gave you to get that reference angle. All right, the next one in quadrant, this one that lands in quadrant 3, all of these are a little bit different. So notice the angle is going all the way from the initial side all the way to this terminal side, lands in quadrant 3. If I draw the triangle, notice it's now below the x-axis. So I've gone all this pi plus a little bit more, okay? So what they're saying to do on this one is you do the entire reference angle, and then you subtract pi, or you subtract 180. Because you're trying to get rid of the chunk, part of the chunk here.
So to clarify, that was
clarify for me. I'm not doing a good job.
That's okay. You take the entire angle and subtract out the pi. That gives you the reference angle.
Yes.
For that one.
Yep, because we're trying to take out this chunk right in here to figure out how much is left in this spot here. So we're trying to figure out what's left. Go green. To figure out what's left in that spot there. Okay. Perfect. Are we good now?
Yeah, you're good.
Okay. All right. And then for this last one, we're now, our initial side is in quadrant, or is on the x-axis, and then our terminal side's in quadrant 4. So it looks like we almost make it all the way around, but not quite. So in order to find the reference angle in this one for our triangle, we would take 2 pi, or 360, which we know is an entire circle, and we would subtract whatever the original angle was. All right, so we're just going to practice calculating some of these reference angles. Not quite there yet, okay? All right, so I'm going to start with 300, and I do like to draw the picture so I know where it lands. I don't have it on that particular unit circle. So I know if I was looking at my unit circle, that my 300 would land me somewhere in quadrant 4. I also know that because that's 270 degrees and this is 360, so it's got to be somewhere in between there. So my entire angle would be that angle, and right in here would be my reference angle, which I could put the little mark on. So we're actually supposed to sketch it. So I did my sketch first.
Good
now
job.
I'm going to actually do the calculation. So because this one goes almost the entire circle, to get my reference angle, I'm going to take 360 and I'm going to subtract the 300, which is just 60 degrees. All right, the next one, of course, is trickier because we gave you a negative. So we have to figure out where that negative ends up going, okay? So if I was going to write my angle measures backwards on this unit circle, I know I would, or in the clockwise direction, right? I would be going -90, -180. I could probably stop there because I know -135 is going to land somewhere in between those two. I'm not going to draw that perfectly, so I know that that's my angle, and I need to figure out what this reference angle is here. And it might not perfectly fit the formula. So the way I look at this one is that there is 180 degrees there. So I'm going to take the 180 and I'm going to subtract that 135 from it to calculate that reference angle. So 180 minus 135 would be my reference angle. So my reference angle is going to be I'm losing
45.
45 degrees. I'm looking at my notes. I'm going to skip example 12, Ms. Rondo, if you're okay with that.
I think
Yeah.
that's fine.
That's a bad one. We're not going to assign that for homework.
I think you could skip 11 too if you really want to, but
I think, well, I'll do 11. It's okay.
okay.
All right. So we have our unit, or our I'm going to draw my axis again. I got to get to 323 degrees. And yeah, we could have probably skipped this one, but that's all right. We'll do it.
Fine.
So we've got 323 has got to land in quadrant 4 because it's between 270 and 360. So I'm going to draw something in quadrant 4. It doesn't matter if we get it perfect or not. So I know that that's my theta. And this is my reference angle there. And again, it looks like I went almost all the way around the circle. So to calculate my reference angle, I would do 360 minus 323, which equals 37 degrees.
37?
Oh no, is that the favorite number?
That's amazing.
Is that the favorite? Well, that was the favorite number, right?
That is my favorite number. And to think I was going to have you skip it, oh my gosh.
That would have been rough.
Yes.
All right, is this where you take over? Or no, I go to 17?
Nope. Yep, to 17.
Okay, thank you, because I keep, my brain is not keeping track of what I need to do today. So it's probably because calculus is kind of over. So
yeah,
we're taking the week off, and then we're going to go back to it next week. So, hey, shh, quiet. All right. So we've got we're going to do this basically the same thing. But we're now going to add in the fact that we're going to try to find the sine, the cosine, and the tangent based on the reference angle. Okay, so, and I'm probably going to approach this, well, let's see. All of them might have a slightly different approach on it. Okay, so I'm starting with 4 pi over 3. So I'm going to see if, first of all, if that's on my unit circle over here. And so I'm looking. Oh, yay. Sorry. There's 4 pi over 3, which, yay, that means I don't have to do any weird calculating. So I just have to find the sine, the cosine, and the tangent. So sine of 4 pi over 3, cosine of 4 pi over 3. I'm sorry, that's going to keep being annoying. Oh, boy, it jumped all over the place. All right. I signed her up for something, and then she's in class with her real teacher, so, oh, well. She doesn't get to go see Amy from Big Bang Theory. I only signed up because I wanted to attend it, but, you know. We're here. Yep. Okay. Remember, it's the cosine, comma, the sine, always alphabetical order. So I'm starting with the sine, which is the y coordinate. So negative square root of 3 over 2. I'm literally reading it out of the unit circle. When we decided we're going to give you a little assessment on this, you may have your unit circles out. So make sure you've got them printed or sketched out or written. We don't expect you at this point to have it memorized. Okay. Even though we've taught you how to do that. Eventually, we'll get there, but not right now. And then the cosine is the x value, so we've got negative 1/2. Now, we can't just read the tangent out of the coordinate, unfortunately. But we do know that we've learned the property that the tangent is the sine divided by the cosine. So I am going to write the sine over the cosine. So my sine is negative square root of 3 over 2 divided by my cosine, which is negative 1/2. I'm going to show a long way step on this, and then I think we're going to go back to, I think Ms. Rondo may have showed you the shortcut last week, but I'm just going to make sure we understand why. So the 2 double negative is going to go positive. And then remember, when we have that complex fraction, we're going to multiply by the reciprocal. And that's going to allow us to cancel those 2. So my final answer is really just square root of 3. Now, super easy, nice shortcut. Anytime you see that denominator matching, we can just cross it out and we just get whatever's left behind. Okay, so that's a nice shortcut that most people like to take. All right.
Mrs. Ballard,
yes,
if I can throw that out. Yeah, yes, we did talk about that a little bit, and I'm glad you brought it up again. If I can reiterate, the actual process that Miss Ballard just showed, where you multiply by the reciprocal, that's a really important skill for stuff later in trig that we may not get to. But also when you're in calculus, you have to rewrite things sometimes in different ways to be able to see different things. So having that skill of being able to multiply by the reciprocal is actually really important.
Yeah, but like she said, when we can see a nice little shortcut, because we do sometimes get a lot of work on our paper, it's not a bad idea to have that shortcut in our pocket and just take it. So
absolutely.
And I am totally okay with that shortcut. So I prefer it. So
Yes, same.
All right. So let's go ahead and look at example 14. So in example 14, you'll notice that that one is not one that's on our unit circle, and I don't have the right unit circle because I don't have the one with the degrees on it. But we don't have that one on the unit circle, and it went in the negative direction. It went clockwise instead of counterclockwise. So I'm going to try to get it onto the unit circle, and to do that, I'm going to add 2 pi, or in this case, add 360, just like we learned a few days ago. When I do that, I end up with 150 degrees. So now I need to find the sine, the cosine, and the tangent of 150 degrees. Now, again, I didn't pull out my correct unit circle. But
Mrs. Ballard, how do we know that 150 degrees and negative 210, how do we know those are the same angle?
Because they're coterminal.
Oh, okay, got it.
Yes. So we need to figure out where they're coterminal, and if I don't have the right unit circle, I can always do this. This is probably a good review. Remember, we can convert it to radians by multiplying by pi over 180. So we've got 15 pi over 18, which looks like 3 can go into that. 3 goes into 15 5 times and into 18 6 times. So now we've gotten our little bit of review because I didn't pull out the right unit circle. I could say I did that on purpose, but I didn't. So we know that
totally
pi over 6 is the same as 150. So I know that I'm using this coordinate right here. Again, sine is the alphabetical order. Cosine first, sine second. So my sine is positive 1/2. And my cosine is negative square root of 3 over 2. And then tangent again is the sine divided by the cosine. You'll notice I've now gotten lazy and just abbreviated to the letter. So my sine is 1/2, and my cosine's negative square root of 3 over 2. I'm going to take the shortcut that we just talked about. I know that those denominators are the same, so I'm going to get rid of them to simplify because I'm lazy. Ms. Rondeau's not the only lazy one. I'm lazy, but I don't like that radical in the denominator, so I am going to rationalize my denominators. We've got negative square root of 3. And then negative times a negative would be positive. Square root of 3 times square root of 3 is itself. What's under the radical? 3. All right. How are we doing on time, Miss Rondeau?
We are doing fine. It's 10:25. So
okay.
You're up to your last example. I don't know what number I told you, but 15 is the last one.
15 is the last one. Awesome. Okay. All right, I'm going to keep going then. I'm going to see if I can squish it in here. Obviously, when I put the notebook into OneNote, I need to make more space. So I have to fix that for next year. It's not happening right now. All right, so 11 pi over 4. I'm curious to see if 11 pi over 4 is on my unit circle. So I'm going to kind of look at my unit circle here. I see pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I don't have 11. So there are a couple of ways I could get it. I could subtract 2 pi. Okay, so if I did that in 2 pi, I can't just do that. I have to make it an over 4 world. 2 pi is 8 pi over 4, which means I really have 3 pi over 4. Or I could just count. Okay, so that's another way to do it. I know I have 1 pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, and I landed on that coterminal angle of 3 pi over 4 again. So 2 different ways you can do it. You get to choose, okay? All right, I am going to calculate the sine, the cosine, and the tangent again. So 3 pi over 4 and cosine of 3 pi over 4. So before I do those, Ms. Rondeau, I'm going to ask a question. So by the time I get to the tangent one, it's in the chat.
Okay.
So what am I going to have to do to calculate the tangent? How do I do that? I'm going to pause, and then I'm going to do my sine and my cosine. All right, I'm going to do the sine and the cosine. So my sine, again, is alphabetical order, cosine comma sine. My sine looks like it's square root of 2 over 2. And my cosine is the x value, which is negative square root of 2 over 2. Did we get an answer, Ms. Rondeau?
We did. We got a couple answers.
Awesome.
And they were both sine over cosine.
Awesome. We have to do the sine divided by the cosine. Great. Okay, so my sine, again, is the square root of 2 over 2. And the cosine is negative square root of 2 over 2. What is super awesome about that? What looks good about that, Ms. Rondeau?
It looks like we could cross out some denominators there. There's a shortcut
Okay,
in
we
there.
could cross out some denominators. That sounds like a good idea.
You could
Okay.
do that, but I also see matching square roots.
Ooh, so maybe I shouldn't do that yet.
Maybe not.
Maybe isn't the numerator and the denominator basically the same number?
It is.
So isn't that just 1?
I believe it is.
So, but it's got to be negative because of this one. So we'd have a -1. It's kind of like saying we had smiley face divided by negative smiley face, and that would reduce to -1. So it doesn't matter what we have, as they match, they're going to reduce to 1.
Can you have a negative smiley face?
Well, wait, I think I can. Watch this. Okay, I didn't draw that properly. So here's smiley face, and here's negative smiley face. Andy thought that was great. All right.
Great.
I am going to stop sharing my screen, and I'm going to have Andy come on and tell the joke of the day, because I know that it's super important to get that joke of the day in here. I am getting back here. Oh, Andy is here. All right, Andy. Oh, 2 jokes today, right?
Yes.
Because we're just twice as good as we were yesterday, I guess.
Yes.
All right, so what's the joke?
Why should you not be afraid of advanced math practice?
Why should we not be afraid of advanced math practice? I don't know why.
Because it's easy as pie.
Because it's easy as pie. He's looking up the second joke. oh no! Did you hear it? Did you hear what he did? Okay, Andy.
No.
Okay, do that again. Do the sound again. Make your
okay,
volume
okay,
super
okay,
loud.
okay,
Sorry,
okay,
this might be. Okay, go. Do the sound again.
Right, I gotta get back to it.
Okay. Oh, the Chromebook's being slow. He did like the drum. There it goes.
Very nice.
All right, do you have a second joke?
Yeah, we do.
Quickly, because we're running out of time. We want to make sure.
So,
okay, we'll come back to the second joke later. He needs to.
Okay.
Ms. Rondeau, would you share your screen and let's get us through the end of this lesson?
Absolutely.
Okay, all right.
Sorry, I'm getting there.
It's okay.
All right, so I think we're not on example 8. We were on 16. Okay.
Yes, we are on 16.
All right.
Fantastic. Okay, so picking it up at 16, find the indicated trigonometric value in the specified quadrant. So they tell us where we're at, they tell us what our function is, and they want us to find the cosine. So this actually you could do a couple of different ways, and I don't know that I pulled up unit circle. You could do this one with the unit circle if you were super savvy.
There's one on. I think there's one in there if you want it. If you go up a slide, maybe.
No, I know there's one later for sure. It's okay.
Oh.
Well, I will show it. I will show you guys how to do this one with the unit circle, but since the next one you can't do with the unit circle, I'm going to show you the longer way here. But if you look at this problem, when you see 1/2, eventually you'll hopefully recognize that that is a special triangle value. So if I look for 1/2, that's what I'm going to look for on my unit circle. Specifically, since we're looking at sine, I'm going to be looking for a y value that's 1/2. So I'm going to flip through a bunch till we find there's a unit circle. So if I look at my unit circle, and I'm supposed to be in quadrant 2 specifically, I'm going to look at all my y values, and I'm looking for a y value of 1/2. Is there one there that is 1/2? Yes, there is, right here. So I could quickly say, all right, my question was find the cosine. That would be the x value. So using that unit circle makes it super fast if you recognize that that would be my sine and this one is my cosine. So the answer should be negative square root of 3 over 2. So I'm going to get rid of this for a second. We're going to go back and we're going to see if we can create that same answer kind of the old-fashioned way. And hopefully I'll get this right. We said it was negative square root of 3 over 2.
Correct.
All right. So that would be using the unit circle, which is, of course, where we want to go and be able to recognize that. If you didn't recognize it, what you could do instead is draw the picture in quadrant 2. And so there's my angle would be measured all the way around to there, but my reference angle is here where I draw my triangle. And then I know sine is y over r, or opposite over hypotenuse, whichever way you want to do that. So I have, from my picture, I'm looking for 1 and 2. Why do I feel like something's wrong, Mrs. Ballard? Look at this for a minute for me. I'm not in quadrant 2. That's what's wrong.
Yes.
Oh my goodness. Okay.
That is correct.
Let's actually draw the picture in quadrant 2. Okay. I'm sorry about that.
No worries.
Wow. I've had a really rough morning today.
You have your coffee there? I think you might need a sip.
Yeah, let me take a drink. Wow. Okay, I was like, this does not look right. Okay, let's actually draw it in quadrant 2. Much better. All right, so the angle is here. The reference angle is here. So sorry about that, guys. Whew. Okay, so there's our reference angle. And again, doing y over r, this makes so much more sense. 1 is our y value, and then 2 is our radius, or opposite over hypotenuse. Hopefully, you guys should start to recognize this. The hypotenuse is twice as big as this other side, which means a 30, 60, 90 triangle. But even if you didn't, you could do Pythagorean Theorem. You could call this x and do x squared plus 1 squared equals 2 squared. So you could solve it and figure it out. This side has to be square root of 3. But because of its location, remember looking to that point up here, what's the ordered pair? This is actually negative square root of 3 because of location. And then, I'm sorry, I lost my train of thought. And then if we were doing the whole point, it would be negative square root of 3, comma 1. Now here's an interesting question. How come when I write that ordered pair, it doesn't look like the ordered pairs that we had on the unit circle? That's a good question. Mrs. Ballard,
That
we need
is
to
a
check
good
the chat.
question.
Why does my ordered pair not look like the ordered pairs on the unit circle?
So see if you know it, put it in the chat. Nothing yet, Miss Rondeau.
That's all right. It's kind of a tough question.
It is a tough question.
That's all right. I'm going to go ahead and move forward. You let me know if someone comes up with it. I'm not going to answer it immediately. I'm going to actually see if I can figure out. So our goal was to find cosine of theta from the triangle that I drew from the reference angle right here, as this is my reference angle. If I do the cosine, that would be adjacent. Remember, a cosine is adjacent over hypotenuse, or we could call that x over r. If I put those values in, I get negative root 3 over 2, which matches the answer that I got before. So the only question going back to that is, how come my ordered pair looks different? And here's the reveal. Do we get any answers?
Nope.
Okay, so here's the reveal. Actually, I'm going to ask a different question to get you guys to hopefully come up with it. What does the radius equal on the unit circle?
Ooh, so everybody, what's the radius equal to on the unit circle? Any unit circle. What's the radius supposed to be equal to? Ooh, I got a 1.
I got a good. I like it. 1. Yes, the radius is always 1. Then looking at my picture, what is my radius currently drawn as? It's drawn as a 2. So if I wanted to represent the unit circle, I could go through and divide every single side of my triangle by 2. to make my radius equal 1. It's a whole lot of background stuff that we don't often get into, but it's kind of important that all of these ratios are the same. I got the same answer whether I was using the unit circle or not, because the relationships are always the same. So if I was truly doing the unit circle, though, I would have these would be divided by 2 because I want a radius of 1. If you didn't quite grasp all of that, that's okay, but that's kind of the explanation as to how that all connects and works. Are there any questions?
I don't have any at this point.
Awesome. Okay. So if I go forward then, we'll try this one. So this question, we're in quadrant 3. Ooh, this time maybe I'll draw the picture correctly. And 13 over 5, negative 13 over 5, that's not a number that sounds familiar from my unit circle. Usually the unit circle values are 1, 2s, and 3s. So 13 and a 5 is probably not the unit circle. So I'm just going to draw my picture in quadrant 3. I nailed it. Quadrant 3. Woohoo!
Good job.
I know. Thank you. Yes. Sometimes it's a challenge, apparently.
You
All
need,
right. So
you need a positive smiley face over a positive smiley face for that one.
there you go. A positive over. Yes. Very nice. So here's my reference angle. And with cosecant, that remember is the reciprocal of sine. So it would be hypotenuse over opposite, or we would call that r over y. So if I go to my picture, my hypotenuse or my r is 13. Remember, we talked about that radius is always going to be positive. So this negative is going to go with the 5. And you can see that here, my opposite, because of the location, remember getting to that ordered pair, that location on the graph is going down 5. Okay, so I have 2 parts of my triangle. You could do Pythagorean theorem to find the missing side, but if you recognize this is a 5, 12, 13 triangle, that would be one of our Pythagorean triples. Or again, Pythagorean theorem, you could do negative 5 squared plus x squared equals 13 squared and solve. Either way, you're going to end up with 12, but there's something wrong with my 12. Help me out. Type it in the chat. What does my 12 need?
Oh, yeah. I think there is something wrong with your 12. Everybody, can you tell us what's wrong with her 12?
Besides the messy writing.
Genesis says negative.
Yes, it has to be a negative 12 because, once again, looking towards plotting that point on the terminal side, this is negative, apparently I don't know my ordered pairs, negative 12 comma negative 5, right? So it's a location issue. It has to be negative. All right, so we got all the sides of our triangle. We're supposed to be finding tangents, which again is opposite over adjacent, or that would be the same as y over x. So if I look at it either way, you can do it from the angle, opposite over adjacent, or from the ordered pair, y over x. We get negative 5 over negative 12, which we would fix that up. Negative divided by a negative is positive 5/12, which if we double check, all students take calculus, tangent should be positive. So good thing we came up with a positive. All right. Survived those couple ones. Now we're going to change directions just a little bit. It's still kind of basically the same thing, but they're giving us different information to start with. So they tell us the cotangent is negative 5. The first thing I'm going to do before I go any further is I'm going to make that a fraction. Remember, all of these trig functions represent ratios. So that's going to maybe help me to see something in a minute. And then I see that I have sine theta is greater than 0. From our previous lesson, if we're saying greater than 0, we mean positive. So I have cotangent is negative, or remember that's the same as saying tangent's negative, and sine is positive. So I'm going to go to good old all students take calculus. I need sine to be positive and tangent to be negative. Here's another question for the chat. I just love my chat questions. Which quadrant should I be drawing my picture in?
Okay, so tangent is positive and sine is positive. So what quadrant do you guys think? And remember, it's supposed to be Roman numerals. So 1, 2, 3, or 4.
Yeah, tangent's negative, sine's positive.
Oh, tangent's negative. I apologize.
No,
I said
that's
it
okay.
wrong.
That changes the
Genesis,
answer.
you answered the correct question for what I said. I did it wrong, though. So everybody, tangent's negative and sine is positive. So try
That's okay.
again. Good job, though, Genesis. You were listening.
I mean, I've never made a mistake like that. Never.
Oh, yeah. Summer is saying 3.
3. Okay, if I look at quadrant 3, I have the t for tangent to be positive. Do I want tangent to be positive?
Ooh, I don't think we did want tangent to be positive. I think we
got
wanted
mixed
tangent
up.
to be negative.
Right, we want
Oh,
tangent to be
Casey is
negative.
saying 2.
2, all right, let's check 2. If I go to 2.
She did the Roman numerals, too.
Fancy. This tells me sine is supposed to be positive. Did I want sine to be positive? Yes.
Yes.
Perfect. Okay, so in quadrant 2, sine and cosecant will be the only positive trig functions, which means tangent would be negative. So this is the quadrant I want to work on. I'm working in quadrant 2. Okay, so I'm going to draw my picture. And there's my, always draw it to the x-axis. Here's my reference angle. And I'm going to do cotangent is adjacent over opposite, or this would be x over y, or you could call it cosine over sine. Look at all those fabulous labels for one number. Any way you want to think about it, all of those are correct. So on my picture, adjacent over opposite, and I'm going to double check, did I get my negatives in the right location? Because a negative could have come from the top or the bottom. It looks like I did. I go back 5 and up 1. Then I just need to figure out what is my radius. So this one is not a Pythagorean triple, so I'm going to do some Pythagorean theorem. 1 squared plus negative 5 squared equals r squared. 1 plus 25 is r squared. 26 equals r squared. Square root both sides. And because we're talking about the radius, I'm going to keep this as a positive square root of 26. If you could break down that radical into something useful, we probably would, but it doesn't. So I'm going to leave it as square root 26. And I am supposed to be finding the remaining trig functions. So the only one we were given is cotangent, which means basically all the others. Starting with sine, that would be opposite over hypotenuse, y over r. Excuse me, several ways to think about that. So that should be 1 over root 26. And I will actually follow Miss Ballard's lead here and we'll flip it before I rationalize. So cosecant would be square root 26 over 1. You can leave it that way.
But just came to the dark side, guys.
Oh, no. All right. But you could write it as just square root 26. All right. And then I'll go back and rationalize it. And I get root 26 over 26. Then I'm going to go to cosine. That would be adjacent over hypotenuse, or x over r, negative 5 over square root 26. And here I go, apparently the dark side. I didn't know that that was, you know, a force. Force is strong with me. Okay, so then if I flip it, I get root 26 over negative 5. That's fine for that one. This one, when I rationalize, I get negative 5, times the square root of 26 over 26. And then we have tangent. I can build tangent myself, or I can go back. We actually were given cotangent. So I could just flip that one and say it's negative 1/5, and then cotangent we already have was negative 5 over 1, or just negative 5.
I like that flipping. That was really cool.
Yeah. You could, again, build it from scratch. We have all the notes there that it's x over y, adjacent over, I'm sorry, that's all cotangent, but you could do tangent from y over x, opposite over adjacent, all those lovelinesses. But
and not that we're going to build the test in this context, but for everybody who's listening, if I'm trying to buy myself points on a test, not that that's what we always want to encourage, but if I saw that cotangent right away, my brain automatically says I'm going to flip to tangent. So I would have probably done the tangent first, and then then done my other ones. So,
which, yeah, definitely makes sense. Take what they give you, and definitely a lot of times I'm sure Mrs. Ballard does the same. A lot of times in class, I won't even try to answer the question. I'll just say, hey, I know this, so I'm going to write down the 5 things I know.
Yeah, and I do that a lot too.
Yeah. Okay, so let's scoot along to, we're going to skip 19, 20, and 21. Those are all calculator ones. And
Yay.
yay! That jumps us over to 22. Find 2 solutions to the equation. Give your answers in degrees and radians, and do not use a calculator, but we are going to use our unit circle. So we're showing our work on this one. Honestly, I would expect you to just pretty much tell me the answer from using the unit circle. But if we wanted to show something, we could show taking the inverse. You guys did this yesterday with Mrs. Ballard. I'm going to do the inverse cosine of cosine. This is my way of dealing with the function cosine. It's the opposite of cosining something, is to inverse cosine it. And if I do it to one side, of course, I have to do it to the other. And then this would give me my angle theta is equal to, so those cancel out, kind of like logs do. And I have cosine inverse of √2/2. So that's how you would show work. I probably won't show that on the other ones. I'm just going to work with the angle, with the ratio. So here's what we're looking at is we want to find this ratio. We're looking at cosine. So I'm looking for an x value, and I want to find it on the unit circle. It says I'm supposed to find 2 solutions. And so I can just look right away, or I can actually use some knowledge that we have. All students take calculus. Looking at cosine, I know cosine will be positive in quadrants 1 and 4. So I can narrow my search a little bit. It's not a huge deal. It's not like the unit circle is that big, but you can be a little strategic in your search. I'm looking quadrant 1 and I said, hopefully not 2, 1 and 4. The quadrants are a little crazy today. 1 and 4. So here we go, unit circle 1 and 4. I'm looking for an x value of √2/2. And that should become a very familiar thing. That's going to pop up. Here's quadrant 1 and quadrant 4. So then I want, what is the angle? There's my angle of pi/4. Here's my angle of 7 pi/4. All right, so if I pop back, and mine doesn't have degrees either, Mrs. Ballard, so we're just practicing a lot of stuff today. Okay, so I would say theta is going to be pi/4 and 7 pi/4. Those are my 2 solutions, but I need those in degrees. So the first one, you guys honestly really should know. That's one you need to practice learning. Pi/4 is 45 degrees. You should just know that. Not because you're amazing, but because you practice. You know, pi/4, you've done it 100 times. It's 45.
You all are amazing because you showed up today. So.
That's true. You are all amazing. For 7 pi/4, you know it's going to be some multiple of 45 degrees. You could do it by just taking 45 degrees and multiplying by 7 if you're savvy. If you're not quite sure, just go back to turning it into degrees and do 180/pi. This will cancel your pi's. You can do some more canceling here. 4 goes into 4 once, or you can use a calculator, it's fine. 4 goes into 180 4 times. That's not right, 45 times, that's what I meant. And then you're just doing 7 times 45, which I believe is 315. I don't know, I didn't get my calculator.
Yes, that's correct.
Thank you, 315. So that was do 7 times 45 is 315 degrees. Okay, so that's radians in degrees, and we're going to do that 3 more times. But again, that unit circle is a big help. Okay, so there's my unit circle. Here we go. So this one, we're doing almost the same problem, cosine again. We have √2/2, but this time we have a negative. So cosine, we're using an x value. We have a negative, so I'm going to go, all students take calculus. Last time we looked for positive values. So positive places would be the first quadrant and the fourth quadrant, which means negative is going to be quadrant 2 and 3. So same kind of thing. I'm going to go forward and look at this. Quadrants 2 and 3, x value of negative √2/2, negative √2/2. My angles are 3 pi/4 and 5 pi/4. So then I'm going to go back and say theta has to be 3 pi/4 and 5 pi/4. And then I'm going to translate that back into degrees. So again, that would be multiplying, taking your angles like 3 pi over 4 and multiply by 180 over pi and work that out. If I have that one correctly, I believe it should be 135 and 225.
Correct.
Doing quick math in my head. Okay. All right. But you guys can take the time and you can use a calculator to do that part. Even though it says don't use a calculator, the point is to not just type it into your calculator to get the answer, but to actually use the unit circle and so forth. All right. Our lasty two, here we go. This one, cosecant theta equals 2. I'm going to immediately make that a fraction. So that means I'm looking for cosecant to be positive. I'm going to do a quick helper since most of the time we deal in the world of sine, cosine, and tangent. We do add in the others. I'm going to say my sine would be 1/2 because this one I know is just a straightforward y value. So I think it's a little easier to do it in terms of sine to find it on your unit circle. So we're looking for a y value that's 1/2. Going back to all students take calculus. This time I want sine to be positive. So I know I'm going to be quadrant 1 and then also quadrant 2. So I'm going to go forward and look for a y value that's 1/2 in quadrant 1 and quadrant 2. So quadrant 1, I see a y value of 1/2. In quadrant 2, a y value of 1/2. My angles are pi over 6 and 5 pi over 6. So I'm going to go back and I have for theta, I don't like that that looks like divided by y. It's really bothering me. Sorry, it's not supposed to be divided by y. So I want a y value for sine. Okay, sorry, that was really bugging me. It's better now. Pi over 6 and 5 pi over 6, I believe is what we had. And then the first one, when I translate to degrees, pi over 6, again, we should kind of just know that one. That one's going to be 30 degrees. Also, if you don't know it in your head quickly, you can do pi is the same as 180. So you could do 180 divided into 6 pieces. It's 30 degrees. And then the last one, 5 pi over 6, I believe that is 150 degrees when you translate it. Mrs. Ballard, does that look right?
That looks perfect.
Great. All right. Then our last one, example 25 for the day, cotangent theta equals negative square root of 3. My very first thing, once again, so I'm always going to look at these in terms of ratios. Since I have cotangent, cotangent's a little different because it uses x and y versus like sine uses only y and, or typically on the unit circle, only y, and cosine uses x. But tangent and cotangent use both. So you could do it as cotangent or you could switch it to tangent if that makes you happier. You could do 1 over root 3, but you won't find that value on the unit circle. You'd have to rationalize it. So might be a little more work to do tangent. I'd probably just stick with cotangent again, because they both, tangent and cotangent, use the x and the y coordinate. So cotangent would be x over y. This one is going to be a little bit trickier. So we're looking for x over y. When we do this, well, actually, hold on before I go. Just going crazy here. Too many things at once. I want to make sure I look for a negative. So I'm going to go back to my all students take calculus and let's see where a negative value is going to be. So all students take calculus. Remember, cotangent goes with tangent. So positive places would be quadrant 1 and quadrant 3. So I'm going to be looking in quadrants 2 and 4. All right, so 2 and 4. And I need x over y to be root 3 over 1. Okay, this one's going to be a little bit trickier. I said I need, was it negative? Sorry, negative root 3 over 1. Okay, negative root 3. I'm just jotting this down for a reference. And this is supposed to be x over y. So when I look in quadrant 2 and quadrant 4, this one's a little different. I'm looking for a square root of 3 in the x spot. When I look in quadrant 2, I see a square root of 3 here. Now, it has the over 2 business there, but everyone, hopefully we see negative square root of 3 in my x position. I'm going to hold on to that for a minute. Yeah?
Yeah, I do.
Good. Then I'm going to double check. I'm supposed to have in the y spot, I'm supposed to have a 1. If I look at the ordered pair, the whole ordered pair, so that was my x. If I look at the whole ordered pair, in my X spot, I have the square root of 3. In the Y spot, I have the 1. I still have the negative that I need. So this is going to be my ordered pair. If I check it, I'm supposed to do X over Y, negative root 3 over 2 over 1 over 2. My denominators, there's that trick, are going to cancel, and I end up with negative root 3 over 1. So hopefully you can see how that works. Even though they have the denominator of 2, because those denominators match, when we make our fraction, x over y, they're going to cancel out. So we're really just looking at numerators when we do cotangent and tangent for this type of activity. Okay, so we have one of our angles is 5 pi over 6. I'm going to jump over to quadrant 4. And I'm looking for, again, in the x spot, I need a square root of 3. I see it here. Let's just double check. I have square root of 3. I need a 1. Got it. And I need the negative. Now, this one, the negative's in a different spot. So if I check it, just to make sure, I'm going to still do x over y. So I have square root of 3 over 2 over my y. My denominators cancel. I get square root of 3 over negative 1. Is that equivalent to my original problem, negative square root of 3 over 1? Are those the same?
They are.
They are the same, yes. When we divide it out, we're going to have, if we were putting it in a calculator, decimal approximating it, both answers would end up being negative 1.73, blah, blah, blah. So yes, it is the same. My two angles then are 5 pi over 6 and 11 pi over 6. So theta equals 5 pi over 6 and 11 pi. Oopsie, I don't know why I have pi in the denominator magically. That's special. Okay, 11 pi over 6. And then turn those into degrees. 5 pi over 6, I believe we just said that was 150. And then I believe this one is 330 degrees. And that wraps it up for us.
Awesome.
Oops. And apparently I'm just erasing all the ink. That's okay though.
That's all right. Oh, gee, that's not what my 25 looked like. Interesting. Okay, we're good.
Sorry.
So we are probably going to give you guys, because somebody did ask out of our group that if we were going to take any kind of an assessment on it. So we want to honor that you guys have put some work into this and give you a chance to show us what you know and what you've learned. Remember, we're not going to meet tomorrow. So we're going to meet again on Monday. We'll probably do a little review on Monday. I haven't cleared this with Ms. Rondeau, but I did email her. Maybe a little review on Monday, and maybe do some kind of a fun assessment, like a Kahoot or something like that, on Tuesday, and throw those points into assessment points, so you can up your A's to maybe, I don't know, 130%. So we'll work on that, and then we're going to work on just a little bit more trig for the next, I don't know, we're like week and a half maybe after that, I think. So is there anything else, any other questions, comments, concerns? Andy's here for a joke. Plus, I need to tell you guys that Mrs. Ballard's class had 10 and Miss Rondeau's class had 9 today.
I know, I saw.
We win again. Okay, Andy, quick joke, because Mr. Rondeau and I are supposed to be in another meeting right now.
All right.
Quick. Oh, we lost it?
No. Who's the best at math?
Who's the best at math? I don't know. Who's the best at math?
The Python.
The Python.
Oh.
And Fallon asked a question. Fallon, I have been really slow because I've been dealing with calculus. I will put it in for my class. I just haven't gotten there yet. My next step is getting grades done. So it's coming. Miss Rondeau beat me.
Well, my class, only the test, though I have